Guys, so today we'll be talking about the title oxidation number. So oxidation number is a precursor, or let me say a rudiment of redox reaction. You don't understand oxidation number, you can't do anything on the redox reaction. So we need to understand how to find oxidation number. So what do we refer to as an oxidation number? So imagine we have a compound like calcium triazocarbonate 4, and the question asks you to find the number of oxidation number of calcium in this particular compound. So we need to understand the fact that what is referred to as oxidation number. I'm always surprised when I see some student writing 40 for oxidation number. This is wrong. Oxidation number can never be up to 40. Let me give you a secret. Don't worry, it's just a secret. Oxidation number of any element should never be greater than 8. I can tell you that there is no element that has oxidation number normally above 8. So oxidation number can either be between the range of -8 to +8. But I will be explaining it to you, and I will give you a lot of secrets about finding of oxidation number. Now, so back to my first question before I move on to say that oxidation number can never be 40. Now, what is my insight about it? So, like I said in the first question, that the oxidation number of calcium in calcium triazocarbonate 4. Now, we need to understand the fact that if oxidation number of calcium is asked in calcium triazocarbonate 4, don't forget that calcium reacts with carbon, and it reacts with three molecules, or let me say three subatomics or atomicity of oxygen to form calcium triazocarbonate 4. Now, so each one of these particular elements donate electrons so as to form this calcium triazocarbonate 4, because they have to be a chemical bond before a compound can be formed. So for every compound formation, there is a chemical bond that holds them together. So now from here, so each particular atoms or elements donate a certain amount of electron. The certain amount of electron that is used by an element in bond formation is known as oxidation number. It is the total number of electrons used by an element in bond formation. So the total number of electrons used by calcium in this particular bond formation, so will be so easy for us to do through oxidation number. Oxidation number can also be defined as the number of valence assigned to an element in a bond. So it simply means that the outer number of electron that is used by an element in a bond making is simply called the oxidation number. So to understand the oxidation number, I would love to actually give you to give you some hints. Now you need to understand the fact that oxidation number, like I said, is between +8 to -8. The first question you need to ask that, what gave me the insight? How did I know that oxidation number can never be more than 8? Yes, so today I will introduce you to the primary periodic table. So the primary periodic table explains to students how to find, or the hints to find, the oxidation number. So however, you have to know that as a student, if you truly want to know how to find the oxidation number without doing any mistake, in such a way that once you get your final answer, you can boldly say that no professor in the world can mark you wrong. So it is by knowing oxidation rules. So we are going to look at the oxidation rules as well, because once you know the oxidation rule, I can promise you there is nothing you will find difficult again. So, but before that, I would love to actually explain it to you, the primary periodic table. So because the primary periodic table holds many of the oxidation rules. Once you understand the primary periodic table, you'll be able to deal with some of these oxidation rules. Now, so we look at it one after the other. So the primary periodic table is a mini periodic table, not the advanced one. It's a mini periodic table that is only correct for the first 20 elements. It is only correct for the first 20 elements, and it is being introduced by a scientist known as John Newland. So it's a John Newland periodic table, a modified version of John Newland periodic table, because if you know the history of the periodic table, you realize that during the time of John Newland, there is nothing called the noble gases. But because we have modified it and we have known that it is correct, then guess what? The element will be between hydrogen to calcium. And if I'm talking about hydrogen to calcium, I'm talking about hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. So those are the elements we'll be looking at from the element 1 to the element 20. So please, at the end of this topic, I repeat, there is no one that will not be able to solve any questions on the oxidation. So the Newland periodic table is a mini version of the periodic table. Because don't forget, it's solely correct for the first 20 elements, and it means that in the periodic table you should be expecting first 20 elements. I have a lot of secret to tell you about the periodic table, and I will do justice to them in a fast way so that I won't take your time. So the hydrogen. So you take it like this. Don't forget, periodic table start from hydrogen. So move on to helium. So move on to lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So followed by sodium, magnesium, aluminium, silicon, phosphorus, sulfur, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium, and calcium. Now, so in the periodic table, so the vertical arrangement is called the group, while the horizontal arrangement is called period. So we are not dealing with periodic table today. We're dealing with oxidation numbers, so I won't be talking much about that. So now look up. So from here we have to understand the fact that we only have in the advanced period, in the primary periodic table, we only have 8 groups. So in the primary periodic table, we only have 8 groups occupied by 20 elements, and in the advanced periodic table, we have 18 groups occupied by 118 elements. So 18 group occupied by 118 elements. That's the advanced periodic table. So now you see this periodic table. It is a periodic table, like I said. It is constructed by a scientist known as Johann Newland. So Johann Newland actually gave us this periodic table because the periodic table was postulated in 1964, and during that time only 64 elements were known. But unfortunately, the periodic table is only correct for the first 20 elements, and even that time the noble gases has not been discovered. So this group is known as the noble gases. Group 8 to 0 are known as noble gases. So we have group 1, we have the group 2, we have the group 3, we have the group 4, we have the group 5, we have the group 6, we have the group 7, and we have the group 8. So please, I really need you guys to follow me up in understanding this, because once you understand this, I can tell you, you are good to go. Now, you need to understand the fact that in the periodic table, there are many things that are happening. So between the group 1, so in the periodic table, so between the group 1 to group 3, they are called metals. So you need to understand the fact that metals react by losing electron. Metal reacts by losing electron. So metal reacts by losing electron. So all metals will lose their electron. So because of that, group 1, which are called the group 1, they are called alkali metal. The group 1 are called alkali metal. So alkali metal, they are called alkali metal. So their oxidation number will always be +1. Now, but you need to understand the fact and some secret here that hydrogen is the only non-metal that is placed in a metal group. Hydrogen is the only non-metal that is placed in a metal group. So you need to understand the fact that alkali is +1. So it means that the oxidation number of any alkali will be +1. So as you can see, so it means that any group 1, so if I'm in group, I've already explained that to you. So if I'm in group, I'm talking about the fact that if I'm talking about any member of a particular group here, let me use an enlightening pen. So if I'm talking about this member of a group, so I'm talking about group 2. If I'm talking about member of a group, I'm talking about group 5. This is group 7. This is group 8. This is group 4. So I've told you the vertical line represents. So the vertical line simply represents what is meant by the word group. So between groups 1, 2, 3. So the secret here is that group 1 will bring down their 1. So you see, there's no how you don't need this primary periodic table. Know it. It is quite very simple. just know that it is between hydrogen to calcium. So what you're going to do is that distribute hydrogen first, end it with helium, then start lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon. You understand? Up to the far you will reach calcium. Now let's flow back to this. So to really appreciate this very well. Now, so from here, the group 1 to group 3 are called metals, like I said. So metals always give out electron. So anything that give out electron will be positively charged. So the ability of an element to give out electron is known as the electropositivity. So group 1 will give out electron and become give out electron and become electropositive. Now please don't forget this, that hydrogen, I've said it initially, that hydrogen is not a metal, but it is placed in the metal group. So it simply means that, what does it mean? Hydrogen is not a metal, but is placed in a metal group. So hydrogen is the only element that can be placed in 3 groups. Hydrogen can be placed in group 1, it can be placed in group 14, which is known as group 4 in the primary, and it can be placed in group 17, which is known as group 7 in the primary. So I will do a video soon on periodic table, you understand better. So that's to tell us that the hydrogen can be placed in group 4, hydrogen can be placed in group 7, but most especially the conveniency of the period is always between groups 1 and group 7. So that is where we can place hydrogen to. Hydrogen plays in group 1 and hydrogen plays in group 2. So the sum of everything I just said is that the group 1 element, the group 1 will always be +1. So it simply means, if I'm solving a question, let's say I'm solving a question that contains lithium hydroxide, and the question says that find the oxidation number of lithium. The first question that comes to your mind is that lithium is a member of group 1, so don't waste your time. The oxidation number of lithium will always be +1, because this is oxidation rule. We are going to look at that. So that's the reason. You see, I've not even touched any oxidation rule. You can see oxidation rule is still down, but however, I can tell you that from your primary periodic table, you can know a lot. Oxidation number of any group 1 is +1. So this is very certain already, and it is very simple already. So oxidation rules of a certain element. Now look at what I'm trying to say. So far, hydrogen can be placed in group 1 and also in group 7. It means that hydrogen will behave certainly like a metal and like a non-metal. Now, what do I mean by a metal? What do I mean by a non-metal? So that you can understand well. So I'm just trying to make this topic not to look too much. So I'm trying to make this topic not to look too much complex. So now, you see, between group 1 to the group 3, there are metals. So let's take carbon out, because carbon is a non-metal. The rest are metalloids and metals. So you can see them like this. Leave silicon out. Silicon is a semiconductor. I will display to you. Now, from carbon down to this guy, they are called non-metals. So all metals react by losing electron. So it means that all metals are electropositive. So in the course of my teaching, so I'll be making an emphasis to this group 1 element, and all non-metals are electronegative. So what's the meaning of electropositive? What's the meaning of electronegative? Electropositive means that they will always lose the electron. Look at it. Electron is a negative charge particle. Imagine electron to be like a bad behavior. Because why? Electron is a negative charge particle. So let's say electron is a negative behavior. Imagine a boy that has plenty negative behavior. A boy has plenty negative behavior. That is, the boy is very rich in electron. Let's say in 3 electrons. The boy has 3 electrons. At the end of the day, so a boy with a plenty electron. So an electron is a negative charge particle. Now let's now imagine electron is a negative charge particle. Let's now imagine electron is a negative behavior. So if the boy should lose 1 out of the electron, at the end of the day, the boy will become someone with 2 bad behavior. So automatically, because this boy had lost one electron, one bad behavior out of the three bad behaviors he had. So then we can say that the boy has become a positive person. So anytime an element loses electron, it becomes positive. So please know that. So it becomes positive. So we can now represent this with a chemical equation. So let's say this is sodium. Don't forget, a normal sodium contains 11 proton, and for any neutral element like this that does not have any charge, the number of proton will always be the number of electron. So sodium has 11. So the moment sodium loses one electron, so it becomes Na plus. It means that Na plus you are seeing, it means that sodium has lost one electron. Now let's say that sodium loses 2 electrons. So if sodium loses 2 electrons, so that's to tell us that sodium will become Na2 plus. I hope you are getting my point. So that is the secret there. And if an element gains electron, for example, let's take a non-metal here. So let's take chlorine. So chlorine, if chlorine gains 1 electron, so it's going to become Cl. So instead of positive like the other one that is losing, so gaining of electron means gaining of bad behavior. It means that the person will be more negative. So that is Cl minus. I hope you grab. So that is the secret behind electron gaining and electron donating. So electron donating is called electropositivity, is the ability of an element to give out electron, and electronegativity is the ability of an element to attract electron to itself or gain electron. So as I was saying, that the alkali metals are +1. So if I'm talking about alkali metals, please, in reality, we can extend the trend of alkali metals downward. So we can extend their trend downwards. And what I mean by extending their trend downwards, you need to understand the fact that alkali metals ranges from lithium, sodium, potassium. So if I'm to continue this periodic table, it will be potassium, so followed by rubidium, followed by cesium, and followed by cesium, that is Cs, and followed by francium. So this is the trend, and they have to be 7 in number because we have 7 periods in the periodic table. 1, 2, 3, 4, 5, 6, 7. So they are now 7 in number. So then from there, we are going to go here. So oxidation number. So the real metals, they are lithium down to sodium. You can see their names sound like lithium, sodium, potassium, rubidium, cesium, francium, so they all end with But hydrogen is different. Hydrogen sound like halogen, hydrogen. So it sounds like halogen. It means that hydrogen, that's int for you. Hydrogen belongs to group 7. So, but because hydrogen is placed in group 1, the reason why hydrogen is placed in group 1, there are many reasons. For advanced students, which I do call A-level students. So you will understand that one of the reasons why hydrogen is placed in group 1 is because the electron configuration of hydrogen is ns1. What I mean, hydrogen owns 1s1. So followed by lithium that finish with 2s1, sodium finish with 3s1. So and also potassium finish with 4s1. So this is one of the reasons why hydrogen can be placed in group 1. There are many reasons, up to 11 reasons why sodium can be placed in group 1. Another reason why why hydrogen can be placed in group 1. Another reason why hydrogen can be placed in group 1 is that hydrogen reacts with halogen. So hydrogen can react with halogen. So likewise, all group 1 can also react with halogen. Another reason why hydrogen behaves like group 1 is that hydrogen has 1 as its valence electron, while all group 1 as well as 1 as their valence electron. This is for hydrogen, this is for lithium, this is for sodium. So they all have 1. And believe me, elements are distributed to the same group because they have the same valence electron. So because of that, so hydrogen, lithium, sodium, potassium, so they can be placed in group 1. So however, hydrogen can also be placed in group 7 too. So due to many reasons as well. Number one reason is that hydrogen can react with metals, or group 7 can also react with metals to form one that's minus one valence electron. So for example, if hydrogen reacts, with hydrogen, so at the end of the day, if you dissociate the reaction, it becomes sodium plus H minus, because all metal will always be positive. Now likewise, the same pattern is also observed when sodium reacts with chloride. So because hydrogen behave like halogen, so it can be placed in group 7 as well. So these are some of the reasons why hydrogen can be placed in group 7 and group 1. And another reason, so there are reasons that support them, and there are reasons that also tell us reason why why they did not really fit into the group 1. One of the reasons why hydrogen did not really fit into the group 1 is because all group 1 elements are solid. Yeah, all metals are solid. Lithium is solid, sodium is solid, potassium is solid, rubidium is solid, cesium is solid, and francium is solid. But however, only hydrogen is gas. So one of the reasons why hydrogen can also be placed in group 7 is the fact that hydrogen is diatomic, is a gas, and all group 7 are also diatomic, they are gases. So I hope that is clear to you. So I believe I've really covered a lot under this particular session. So now, okay, the summary of everything I was trying to say is that all group 1, don't forget, group 1 to 3, I told you, they lose electrons. So it means they lose electron, it means they lose a negative behavior. So it means they will be positive. So they are now a renewed person. So group 1, so all group 1 will be plus 1. So all group 2 will be plus 2, and all group 3 will be plus 3. So you see, when you have this mentality, the whole of everything will be so easy. I'm so happy I'm doing this video, because it has been long. I've wanted to release, if I would say 2 years ago, since 2 years ago, I've always wanted to release a topic, a video on oxidation number. I just believe God just said that this is the right time for me to do it. So for all group 1, they are plus 1. For all group 2, they are plus 2. For all group 3, they are plus 3. Please, this is oxidation rules. So rules are meant to be followed, not to be broken. I repeat, rules are meant to be followed, not to be broken. So it means that if you want to arrive at a good answer like any scholar, so just know that oxidation number of any group 1 is plus 1, for any group 2 is plus 2. So the plus 1 of any group 1 holds for the metal version of group 1. And what are the metal version? From lithium to francium. Hydrogen is the only non-metal placed in the metal group. So it means that hydrogen, it is not really a metal. So it's not even really a metal. It is not a metal, but it is placed in the metal group. But however, hydrogen will also typically behave like a metal. So I will explain that to you. Hydrogen will typically behave like a metal. So look at it, because hydrogen can be placed in group 1 and group 7. So it means that we should be expecting hydrogen to share some characteristics, so like a metals, and also to share some characteristics like a non-metal. So hydrogen is one of the greatest unique elements in the whole world. Hydrogen is the only element without no neutron. It's the lightest element in the world, and the word hydrogen comes from the word water former. So it reacts with oxygen to produce water. So it's one of the greatest unique elements known in the whole world. So now I want us to actually look at some great things here. So great things here. So we have looked at the period of each element. So if you want to copy anything, feel free to pause the video at any intervals to copy anything you want to copy on the screen. So however, we've spoken about the group 1, the group 2, the group 3, the group 4, the 5, 6, and the 4. Okay, this owns for boron, carbon. So the 3, the 4, 5, 6, 7, group 8 or group 0. So alright, so let's move. So we have seen the hydrogen, lithium, sodium, potassium, so they belong to group 1. So from my explanation, I've explained to you that oxidation number of all group 1, so oxidation number of all group 1 will always be plus 1. Oxidation number of all group 2 will always be plus 2. Oxidation number of all group 3 will always be plus 3. Now let me quickly give you a particular illustration to this so that you can fully appreciate what I meant by this. Let's say you have a reaction, and in the reaction they wrote sodium Na2CO3. That's true. Sodium triisocarbonate 4. Sodium triisocarbonate 4. Now, and they underline it that find the oxidation number of sodium. Find oxidation number of sodium. You see, it is only a foolish examination body that will ask you to find the oxidation number of any element. I repeat, from experience, I can tell you this. It is only a kind of a simple exam we ask you to find the oxidation number of any element that is stated in the oxidation rule. Because why? The mentality of every examination body is that you should know how to find oxidation number, and their mentality is that for you to be able to find oxidation number, you must know oxidation rule. That's to tell you that after this topic, you say, like, this video will surely be long because why? I really wanted to know oxidation rule. So it means that after this topic, you are meant to know how to solve oxidation rule. So they are expecting you to know the oxidation rule. So oxidation rules of sodium is typically +1. Why? Because it belongs to group 1. So don't stress yourself. They will know it is very hard. It is very hard they underline group 1, group 2, group 3, because they know that you will know them. They know that you should know the oxidation rule. So if they underline sodium, don't waste your time doing any calculation. Okay, I have to have sodium plus. Don't do that, please. So all you just have to do is that, oh, sodium is a metal, it belongs to group 1, oxidation number, go for the option, oxidation number is +1. Don't stress yourself. No professor in the whole world, or let me say no scholar, no that genius or ingenious person will get any answer different from +1. Because why? It is stated. I have evidence, and my evidence is the fact that it is stated in the oxidation rule that it should be +1. So all group 1 element has +1 oxidation number. So now let's say that this particular element, it is being dimented. It's been dimented for, okay, let's still write NHCO3. In fact, I don't care what the compound may be, sodium will always be +1. So let's say we have another compound as well. Let's say that the compound is being changed or modified into, let's say we have sodium. Let's try to make it looks like a coordination compound. So NH3. So 2+, and you are asked to find the oxidation number of sodium. I don't care what the compound may be. I don't care how big the compound is. So oxidation number of sodium will always be 1+. Don't stress yourself. No matter what the compound may be, that's the summary of everything I'm trying to say. Oxidation number of sodium will always be 1. Yes. So there is an important trick I want to give you here. Please, I need you to pay attention, because I will be saying a lot of things that most time you've never heard about before. Now, oxidation number of any element, I repeat, oxidation number of any element will never be greater than the group it belongs to. Oxidation number of any element will never be greater than the group it belongs to. I repeat that again. Oxidation number of any element will never be greater than the compound the group it belongs to. So it means that hydrogen belongs to group 1. So oxidation number of hydrogen can never be greater than 1. Beryllium belongs to group 2. Boron belongs to all these elements. The oxidation number will never be greater. Look at carbon. Carbon can form 4 oxidation number. So why? So because in CO2, if we find the oxidation number of carbon, so carbon forms 4. That is 4. But in CO, carbon forms 2. So, but however, carbon will never form 6. Carbon will never form 4. Why? Carbon will never form 5, because the group that carbon belongs to is 4. So an element that is not a metal can exist between minus to positive. This is as a result of a magnetic quantum number. So magnetic quantum number explains the number of degeneracy or spatial orientation in the atomic orbitals of an element. So it means that carbon can migrate from -4, -3, -2, -1, 0, +1, +2, up to +4, but it will never go beyond the group it belongs to. So you have to know that. So I don't know why some students are doing this mistake. They will give some students, some student will be given work to do. They can be like, which of the following is the oxidation number of carbon? They write 1, 7, B, -5, C, -3, -3, and D, -8. I don't know why you're stressing yourself. you need to understand the fact that carbon belongs to group 4 in the primary. Try to know this primary periodic table to help you. Carbon belongs to group 4. So its oxidation number will never be greater than its group. So it simply means that this is the only guy correct, because it's not more than 4. But the rest are more than 4. Carbon will never possess this. It's for another element, not for carbon. So oxidation number of any element will never be greater than 4. So please, of any element will never be greater than the group it belongs to. So carbon belongs to group 4. Its oxidation number will never be greater than 4. Now, so please, I need your attention. I want to be explaining some things here. So thank God I've explained the metal version. So now it remains non-metal. I've explained the metals. I said that all the group 1 will be +1, all the group 2 will be +2, all the group 3 will be +3. Yes, I need your attention for hydrogen before I move forward to the non-metals. I told you that hydrogen can behave like a metal and like a non-metal. So if hydrogen is behaving like a metal, it means that it will follow the first rules I gave you, that the oxidation number of all group 1 is +1. So during this time, it means that hydrogen is behaving like a metals. But if hydrogen is behaving like a non-metal, it will be -1. The question is that why minus, why positive? Positive means it's losing electron like a metal, and negative means is gaining electron like a non-metal. Now I need your attention. So why is it that I'm not having +2 plus? I just explained it to you that the oxidation number of an element will never be greater than the group it belongs to. Hydrogen belongs to group 1. So hydrogen can either be -1 or +1. So it will never be greater than the group it belongs to. So now let's continue. So once we understand that, then now, so we want to talk about the non-metals. Yes, we really need to pay attention to this guy called non-metals. So you see, from here to here, you need to understand that all the group 8, the atomic number is 0. Yes, all group 8 all group 8 oxidation number. I said atomic number, sorry. All group 8 oxidation number is 0. Yes, oxidation number is 0. Yes, their oxidation number is 0 because they are unreactive. That's the reason why we call them inert gases. Inert means that they are inactive. So all group 8 are inactive, they are not reacting. So they don't have any effect, and it's because their electron is fully filled. The electron is fully filled. The electron of group 8 elements are fully filled. So they don't need to accept, they don't need to gain. Let me explain the secret behind this. The secret of gaining electron and losing electron is being determined by a rules called octet rule. So octet rule is the rule that explains how bond is formed and how bond is broken. So let's say sodium want to react with sodium chloride. Each one of them must be able to sustain octagon. That's from the word octet. So sodium 281, that's sodium number 11, because if you count sodium belongs to 11, hydrogen, helium, so it falls at 11. So and the 11 is the proton number, which should be equal to electron number because it's neutral. Now let's look for the chlorine 287. So it is easy for, you can see, like what I'm trying to say is that at the end of the day, each one of them are to have 88 as their last electron configuration. So it means that at the end of the day, this 7 must become 8, and at the end of the day, the last number at the back of sodium 2 must become 8. So it is very easy for chlorine to gain 1 than for sodium to gain 7. So because of that, sodium will lose out his own 1 and give it to chlorine, because all metal lose and all non-metal gains. So all metal lose and all non-metal gains. So I don't want to enter redox. I will have explained that using redox, that the loss of electron is called oxidation and the gain of electron is called reduction. Okay, let me just use that opportunity to explain like I said. So if sodium is losing electron, it means that sodium is undergoing oxidation. So because of that, all metals are reducing agents. So because chlorine is gaining, the gain of electron is called reduction. So all metals are oxidizing agents. You can see an interchange of name. I will explain that later. So that's redox, another topic on its own that is being together with the with the oxidation number. Because if you don't understand oxidation number, you can't solve a redox reaction. Now, please, I need your attention. So we have 281 and we have 287. So the 1 here will migrate. So sodium will give out the 1 to this. At the end of the day, sodium become 28 And don't forget, the moment sodium becomes 2,8, it means that sodium has lost 1 electron, so it becomes sodium plus, and chlorine gained the 1 and become 288. That's to tell us that chlorine has become chlorine minus. So with this, they can now both successfully form sodium chloride. So at this point, they can both successfully form sodium chloride, which is normal salt. We call it common salt or normal salt. So that's sodium chloride. So I hope you really understand this. That is, the electron move from sodium to chlorine. And why did the electron move? The electron move so that they can sustain octet structure. So the octet structure comes from the belief of the fact that all elements want to gain, all elements want to gain, all elements want to lose electron, because they want to be stable. So all group 8 are inactive, they are stable, they are rich in electron. So everybody are working because they want to be rich. So all elements are gaining or losing electron because they want to be rich like group 8. So group 8, they are stable, they don't need anything. They are stable. Under normal condition, they are unreactive. But they can be made to be reactive under some certain condition, especially starting from xenon. Xenon is one of their members. But you need to understand the fact that normally all group 8 are inactive. They are not reactive. So they are not reactive because their shells are fully filled. I repeat, their shells are fully filled. So because of that, they don't have to react. So their oxidation number is totally 0. It means that if I'm solving a reaction or anything and they ask me to find the oxidation number of helium, neon, argon, you can actually increase the trend downward. We have krypton as well. So krypton. So they can ask you to find any of these krypton. I think that's Kr. So they can ask you to find any of these elements and so on. So at the end of the day, you should be able to account for the fact that any of the group 8, don't stress yourself, any of the group 8 elements, their oxidation number is totally 0. Don't stress yourself, it's totally 0. Now let's now look at this from carbon, phosphorus, this. Now to get their oxidation number, the simple hint is that you take their group. For example, if I'm to do for carbon belongs to group 4. So 4 minus, what did carbon want to become? Carbon wants to become group 8 minus 8. So it means that carbon is typically minus 4. But that's not real, because it's not stated in the oxidation rule. You see, we are still going to do oxidation rule, as you can see down here. Any element that is not stated in the oxidation rule, I repeat, any element that is not stated in the oxidation rule, they are typically the element that they will ask you to find the oxidation rules. To find the oxidation number. Any element that is not stated in the oxidation rule, they are typically the one they will need you to find their oxidation numbers. So for example, oxygen is stated in the oxidation rule. So oxygen is stated in the oxidation rule. So that's tell us. So oxygen belongs to group 6. And what did oxygen want to become? 8. So you subtract it, that's minus 2. So most especially in normal reaction, oxygen carry minus 2. So all you can see group 7, fluorine. Fluorine belongs to group 7. 7 minus 8 it wants to become. That is minus 1. So that's the reason why fluorine will carry minus 1. And that's the reason why chlorine will also carry minus 1. So like I said, it can extend beyond that. Okay, it can extend beyond that because they are not stated in the oxidation rule. But that's hint for you. So let's come back here so we can look at it and see how it is solved. So now that you have the normal basic understanding about this, so then we can move on to it. So the oxidation rule number 1. So like I said, take your time to understand the oxidation rule. So the oxidation number of hydrogen is +1 in its binary, in its compound, but in metallic hydride it is -1 in metallic hydride. Now, yes, this is quite very simple. I will try my possible best to explain this. So oxidation number of hydrogen is +1 in its compound. It means that any compound you have hydrogen, HCl, NaH, in fact, this will be so good to use. H2SO4, NHSO4, NaH. Yeah, this is 3 types of compound. This compound contain hydrogen and non-metals. Yes, this one contain hydrogen and non-metals. This one contain metal, hydrogen, and non-metal. This one contain hydrogen and metal. Now pay attention. When hydrogen reacts with non-metals, hydrogen will behave. Look at it. It's like a story. When hydrogen reacts with the non-metals, hydrogen will behave like a metal to them. So those non-metal will now be seeing hydrogen as someone who is a metal. So because of that, hydrogen will use the opportunity to take +1 and behave like a metal to them. So for example, this particular compound now, if I'm to dissociate it, H2SO4 being dissociated is going to produce H plus 2H plus SO4 2 minus. So that's tell us that hydrogen is behaving like a metal. So when hydrogen is reacting with a non-metal, hydrogen will behave like a metal to the non-metal. Because why? Hydrogen has been placed in the metal group. So hydrogen has been placed in the metal group. So anytime he's reacting with a non-metal, those guys will be seeing him as someone who is already part of the metallic group. So hydrogen will behave like a pseudo metal, like a fake metals, and in reality it is not a metals. So it means that in this certain reaction, hydrogen oxidation number, don't forget hydrogen belongs to group 1. I told you that the oxidation number will never be greater than the group it belongs to. So hydrogen belongs to group 1. So his oxidation number here will be positive version of it because it's behaving like a metal. Metals are electropositive, that is, they lose electron. Now we have sodium, hydrogen, and SO4 to form sodium hydrogen tetroxide 6. Now in this reaction, hydrogen is reacting with a non-metal. It will have been positive, but don't forget metals is there. So the fact that metal is there, hydrogen will still sustain is what? +1. The reason why hydrogen will still sustain is +1 is because the metal will not want to embarrass hydrogen. Imagine the metal. Of course, the metal is a boss to hydrogen. Hydrogen is a little boy that is quotient is set. So of course the boss wouldn't want to disgrace hydrogen because the boss is proud of hydrogen. So because of that, hydrogen will still be +1. So it simply means that in a reaction where hydrogen is reacting with a non-metal, hydrogen will behave like a metal. Even in the presence of a metal, hydrogen will be a metal. So hydrogen will still react like a metal. But however, the moment hydrogen is alone with its boss, so hydrogen dare not behave like its boss. So it simply means that when hydrogen reacts with a metal, alone in a close relationship like this, there's hydrogen and a metal, so in this reaction, hydrogen dare not behave like a metal in front of a metal. I repeat, hydrogen dare not behave like a metal in front of a metal in a close relationship. So this type of reaction is called metallic hydride. It means metals and hydrogen, metallic hydride. So metallic hydride comes from the fact of metal plus hydrogen. So it gives metallic hydride. So in this type of reaction, hydrogen will surrender its power and behave like a non-metals. So the summary of this particular rule number 1 is to tell us that anyhow or anywhere we see hydrogen behaving like a metal, that is, what are the reactions? It means that anytime hydrogen reacts with a non-metals, anytime hydrogen reacts even in the presence of a non-metal with a metal, it is +1. But if hydrogen is now reacting alone with a metal, hydrogen will surrender its power and become a negative. So you see, if you know this, then I believe oxidation number should not be hard for you. So it means that hydrogen can either be +1 or -1. It is plus when hydrogen is reacting with a metal, plus even when metals is in the association. But if hydrogen is alone with a metal, it is -1. So that's the summary of the oxidation rule. So we are moving on to the oxidation rule number 2. so that we can recap a lot of things. Oxidation rule number 2. So the number 2 oxidation rule says that oxidation number of group 1, so oxidation number of group 1, what happens to this keyboard? Oxidation rule of group 1 is positive 1, is plus 1. So and okay, comma. So group 2 is, don't forget I just explained this, finished. So and group 3 is positive 3. So I just explained this to you, so you don't have a lot of things to be thinking about in this particular aspect. So it simply means that if you have so all these member of a group I just explained to you here, that is any member here, so any member here, so in group 1 it's plus 1, so any member here in group 2 it is plus 2, and member here in group 3 it is plus 3. So that is the oxidation number, plus 1 plus 2 plus 3, that's the oxidation number. So take note of that. So now from there, so that's group 1, group 2, group 3. So the next one now is, we'll move on to the next one. So the next thing that the oxidation rule talks about is the oxidation number of oxygen. So the number 3 speaks about oxidation number of oxygen. Oxidation number of oxygen is -2 in its binary compound. Is -2 in its binary compound, comma, -1 a peroxide. So peroxide, they are compound that have the same atomicity like oxygen. So when I mean peroxide, it means the moment I'm talking about K2O2, or the moment I'm talking about H2O2. So peroxide means they have the same atomicity with oxygen, O2. So etc. So and also it form +1. You can say I'm telling you all this offhand, so you have to know it offhand. +1 in each binary compound. So binary compound with fluorine. So binary compound of hydrogen with fluorine form a compound known as known as OF2. So that's how the compound is. So OF2, yes. So that is the compound. Okay, but +2, sorry, it is +2 in its binary compound with fluorine, +2 in its binary compound. So now let's validate the rules that we just spoke of. So we haven't done anything much. I explained that the hydrogen is +1 when it's reacting with a non-metal, +1 even when a metal is there, so but -1 when it's alone with the metal. So oxidation rules of all group 1 is +1, of all group 2 is +2, of all group 3 is +3, and I've explained what group 1 and group 2, group 3 meant. So for the group 3, so I said that the oxidation number of oxygen is -2 in its binary compound. So look at it. For oxygen, we are having 3 conditions. The first condition is binary compound. So the first condition is binary. The second condition is peroxide situation. And the third condition is fluorine condition. Good. So if you understand this, then it means that there is nowhere you will see oxygen that you won't be able to tell that oxygen is -2 here, -1 here, and it's +2 here. Very easy for you to do. Now look at it. It is quite very simple. So binary compound means any compound that is not peroxide very easy to do. It means any compound that is not peroxide and is not fluorine. So now look at it. So we know that, okay, if oxygen is reacting with fluorine, it is automatically +2. So we've known that already. So I will teach you how you can find or prove this. Now, for peroxide, what are peroxide? Peroxide is any this thing that have the same atomicity. Atomicity means this small number you're seeing below. So is any compound in such a way that the atom reacting with oxygen form the same number of molecules with oxygen. So H2O2, another one K2O2, another one Na2O2. These are peroxide. So in this type of compound, oxygen will always be -1. So as you know that, okay, in peroxide oxygen is -1, just know it, oxidation number of oxygen. So any compound that is not peroxide, that is not this category, and is not fluorine, then it means that in that type of compound, oxygen will always be -2. So let's look at an example of that. Now, example of compound like that is Na2CO3. Yeah, in this type of this now, let's look at it. Find the oxidation number of carbon. Yes. Solution. Some students will think that, how will I find the oxidation number of carbon? It's not possible because I'm not giving sodium on, I'm not giving oxygen on. They won't give you. Yes. Because they are expecting you to know the oxidation rule. If you know the oxidation rule, you'll be able to solve it. Very easy. Now, break it down into atomicity. Know that you are dealing with Na2CO3. So, they do not have charge. You see that it is neutral, so everything is equal to 0. Now, understand that sodium is a metal, it belongs to group 1. So, let's first break it down to atomicity. It means we have 2 of sodium plus 1 of carbon plus 3 of oxygen. Everything is equal to 0. Now look at it. So 2, sodium belongs to group what? Group 1. So its oxidation number is 1. I just explained that. So, but we don't know for carbon. So let's find for carbon. Now I just explained to you now that if the compound is not peroxide, you see the compound is not peroxide. Peroxide is a binary compound that forms 2 atomicity. It means that if that thing is 2, oxygen will also be what? Be 2. That is when we call it peroxide. So it's not peroxide. This is a normal compound. And in normal compound, oxygen will always be -2. So -2, very easy to grab. So 3. So here we have 3 here. So plus 3 times oxygen is -2 now. So everything is equal to 0. So from here 2 times 1 is 2 plus carbon. So -6. Everything is equal to 0. So carbon -6 plus 2 is equal to 0. Carbon -4 is equal to 0. Carbon is equal to 4. But you will write +4. So it means that oxidation number of carbon is +4. So you can see how we are able to use it to get oxidation number. So they won't give you for sodium, they won't give you for for oxygen, because they are expecting you to know it. And this will help. If you know how to find oxidation number, you'll be able to name. If I want to name this compound now, I will say that sodium triosocarbonate 4. Can you see it? Sodium triosocarbonate 4. So that's how people's name, and that is the rules of IUPAC. So how this aspect is clear to you. Okay, and I hope you don't have any problem there. So let's move on to the next rules after the one of oxygen. So that will make it rule number 4. Like I said, ensure you know all these rules because they are going to help. So know them, and that's the reason why I'm taking my time to write them out. So the next rule, which is rule number 4. Rule number 4. So oxidation number of the oxidation number of monoatomic gas, or oxidation number of monoatomic let's write it. Oxidation number of monoatomic diatomic and polyatomic molecule or molecules. So let me just put S here, or molecules is, so it is 0. Is 0. So what I mean by this number 4 being a 0, so please, I need your attention because you need this. So any monoatomic, so if you are asked, if this should be so easy for you, anytime monoatomic comes to your mind, it means an element standing alone. So if I have sodium, so sodium just standing alone, not sodium trioxocarbonate, not sodium hydroxide, it means sodium standing alone, so it is equal to 0. So far it is not forming a compound. So far the sodium is not, if sodium is standing alone, sodium is not forming a compound, it means it's standing alone, so it is equal to, okay, so to make my definition more meaningful, I think I should put in its free state. In its free state or neutral state, is equal to 0, so that you can really appreciate it. So you can see helium is standing alone, is in its free state, sodium is standing alone. I can write chlorine is standing alone. The oxidation number will be equal to 0. So now let's say that they are forming a molecule. Yes, molecule of helium is still helium, so it's still 0. Molecule of sodium is still equal to 0. But molecule of chlorine is Cl2. So far it is standing alone, it's still 0. So it means that if element is standing alone, is in its free state or neutral state that is not carrying any charge, is equal to 0. Now this now apply to molecules as well. Let's say I have calcium trioxocarbonate 4. If they ask me the oxidation number of this compound is equal to 0, because it is what is in its neutral state. So the oxidation number is equal to 0. Oxidation number of sodium hydroxide. Look at it. I didn't say oxidation number of sodium, but I said oxidation number of sodium hydroxide is equal to 0. But oxidation number of K2Cr2O7, this is also equal to what? 0. But the oxidation number of Cr2O7 raised per minus 2 is minus 2. You can see here, what is the difference? If you look at this guy, they don't have charges. So that's the reason why we said they are equal to 0. But in this one, they have charges. So, and that will be our next oxidation rules. So that will be our next oxidation rule. So that will be number 5. So number 1, say that oxidation number of any charged particles, of any charged molecules or ion is equal to number of its valence. So as you all know, valence is the combined power of an element, so it's equal to number of its valence. Now what I mean by this is that if I have, now look at it, this makes it different. I just told you in number 4 that if you have ordinary sodium is equal to 0. But if you have sodium plus, oxidation number of sodium is that plus 1. So if you have calcium trioxocarbonate 4, oxidation number of calcium trioxocarbonate 4 of the whole compound is 0, because they don't have charge. But if it is now calcium diazocarbonate 4 ion, so here the oxidation number is the number of charge, which is minus 1. So if you have potassium heptaozochromate 6, chromate, yes. So here you are going to have the oxidation number of the whole compound is equal to 0. But if this heptaozochromate ion, the oxidation number is equal to this ion minus 2. So that is the meaning. So this one answers rule 4, that is oxidation number of any element in its free state is equal to 0 or neutral state. But the moment it is not neutral, it is either plus or minus. the number one rule is that the oxidation number is equal to what? Minus 2 or minus raised to the power of their charge. That's the oxidation rule. So that's the oxidation number. So the next one now, number 6. Okay, so we have looked at the fact that oxidation number of oxygen monoatomic, okay, the atomic oxidation number of charged molecule is equal to the number of its ion. So that's actually I think I've summarized the oxidation rules to be equal to 7 already. I mean, to be equal to 5. So I guess that's everything we need to look at. Oxidation rules of oxygen of group 1, group 2. Oxidation rules of oxygen is this: monoatomic, the atomic polyatomic molecule in its free state or neutral state is equal to the oxidation number of any charged molecules or ion is equal to the number of its valence. So let's just look at random questions, then that will be all for the today. So just random questions. So we move with class drills. So number 1. So you have to find the oxidation number in the following. So let's say we have K2, Cr2, O7. So number 2. Oxidation number in KMN, O4. Number 3. Okay, just one more. Cr2, O7. O7 raised to power minus 2. Number 4. Number 4. Yeah. Mn, O4. Raised to power minus 1. So we're going to look at the element underlined. Okay, so it will be good if color is given this way. Okay, so we'll focus on the elements on the line. So like this. So we look at this. So we find the oxidation number of chromium, of manganese, of Cr2, of Mn. Now you can see that these elements that are underlined, they are typical elements that are not found in the oxidation rule. Oxidation rule spoke about potassium because potassium is in group 1. It spoke about oxygen, but it doesn't speak about chromium. That's the reason why they were asked you to find chromium. So not that there is anything special about chromium. It's because it is not found in the periodic. It's not found in the oxidation rule. So that's the reason. for manganese, from chromium, and from manganese. Manganese again. So let's quickly solve this. Now, so the number one says that K2Cr2O7. So the number one, we write the solution. Then so the number one rules in solving oxidation is that you ask yourself, did they have any charge? So that go with the what? The fifth. That go with the fourth rules. So the fourth rules says that if they are equal to charge, that's the fifth rule. If they are equal to any charge, they should be equal to the number of their charge. And the fourth one says that if they are not equal to any charge, so they should be equal to 0. So we have K2Cr2O7 should be equal to 0. Then from here we have 2 potassium plus 2 chromium plus 7 oxygen is equal to 0. So then from here we have 2 potassium. Not for potassium belongs to group 1, that's 1. So we don't know for chromium. So 2Cr plus oxygen is minus 2 in this type of compound. You can see the compound is not peroxide. It's not fluorine, so it is minus 2. So from here 2 times 1 is 2 plus 2Cr plus, so we have 7 times minus 2, that's minus 14. Minus 14 equal to 0. So 2Cr, so 2 plus minus 14, that's minus 12, equal to 0. Then 2Cr is equal to 12. Then Cr is equal to 12 divided by 2. Then Cr is equal to plus 6. So it means that the oxidation number of 2Cr is equal to plus 6. So I hope this is clear to you. So the next one. So the next one is KMnO4. So solution to this. So we have potassium plus Mn plus O4. So far they don't have charge, everything is equal to 0, no charge, neutral. So potassium is group 1 plus Mn. Oxygen is minus 2. So 4 of minus 2 is equal to 0. So 1 plus Mn plus, minus 8 equal to 0. So 1 plus Mn minus 8 is equal to 0. So Mn is equal to plus 7. So you understand how I got plus 7. 1 plus minus 8 minus 7. When it crosses equal to, it's give you plus 7. So manganese is plus 7 in this oxidation number. So the next one. So for those solutions I solved, if you want to get your solution, just pause the video at any point interval to copy your solution. So the next one we have Cr2O7 minus 2. So solution. So the first thing, you break them into atomicity. 2Cr plus 7 oxygen, everything is equal to the number of their charge. That's rule number 5. So this one, you see, I didn't say they are equal to any number because they are equal to 0, because they are neutral, so they are equal to 0. But this one, it has charges, so it's equal to minus 2. So we are looking for Cr, we don't know. But we know that chlorine in this type of compound, it is minus 2. So you can see they can't ask you to find chlorine because they know you will know it. They can't ask you to find oxygen rather because they know you know that oxygen is minus 2. So oxygen is minus 2. So it is those elements that are not mentioned in the oxidation rule they will mostly ask you to find. So 2Cr, so 7 times minus 2, that's minus 14, is equal to minus 2. So 2Cr is equal to minus 2 plus 14. Then 2Cr is equal to 12. Divide both sides by 2. By 2 is C. Chromium is equal to plus 6. The same answer with number 1. So the next one. So the next one, we have Mn or 4 minus. So solution to this, so Mn plus 4 of oxygen is equal to minus 1. So Mn plus 4 raised to minus 2 is equal to minus 1. So Mn plus, okay, that is 4 times minus 2 will give you minus 8. So minus 8 is equal to is equal to minus 1, because that's the charge. The charge is minus 1. So Mn is equal to minus 1 plus 8. Then Mn is equal to plus 7. So I hope after this topic you can solve any question on the oxidation rules. So I wish you guys best of luck. So if you have any question, feel free to drop it on the group. So see you guys later.